Okay, so looking at these, we're going to see a few more new functions, and we'll just talk about them as we go, looking at our graphing calculator. The number one thing I want you to do is every time you get a new function is to go ahead and enter it into the graphing calculator, because looking at a picture of every single one of these big ideas can really help us when it comes to understanding things like domain and range and all the other considerations that we need to take. All right, so when I'm looking at this rational function, and it's the parent function of our rational functions having x in the denominator, we look here, we see there's no x and y intercepts. So this graph is going to never touch either of the axes because my horizontal, my vertical asymptote is going to be the y-axis. And when I'm talking about my vertical asymptote, that's going to be where is the y-axis, and my horizontal asymptote is going to be the x-axis. So it's important to kind of look at that. Okay, when x is equal to 0, yes, that's the y-axis. When y is equal to 0, yes, that is the x-axis. That can be a little confusing, to make sure you can maybe draw yourself a little sketch of the plane and recognizing that when x is equal to 0, I'm not moving left or right, which means I'm only ever going up or down on that y-axis. When y is equal to 0, that means I'm never going up or down. I'm only going left or right, which is that horizontal x-axis. There's not going to be any points of discontinuity. So when we're talking about our conversations of domain and range, our domain is going to be everything from negative infinity up to that asymptote, hopping over it, and continuing on. My range is going to have the same conversation from negative infinity up to that asymptote, hopping over it, and continuing on. And I know that as x approaches both positive and negative infinity, y is going to approach that asymptote as it continues. It will approach 0. So if you look at the graph, as x gets bigger and bigger and bigger and bigger, my graph approaches the axis from both a positive and negative sense. Okay. So moving on, we encounter a new kind, and we had just started talking about this. So third period, you got this lesson. Second period, you didn't. But that's not going to stop us from going ahead and entering in that function into the calculator. What we're looking at here is an exponential function. And that exponential function, when we see it, we can see that it goes up on and on forever. And it does have a y-intercept, but no x-intercept. And that asymptote it has is going to be y is equal to 0. It's going to approach my y-axis, but never actually reach it. There's not going to be any points of discontinuity. When we talk about our x-intercept, there's not going to be any, and my y-intercept is going to be anything to the 0 power when I put a 0 in for my x, and understand what this looks like. F of x is equal to 2 to the 0. If I think about that xy ordered pair chart, each of my x values are going to be my exponent. Anything to the 0 power is 1. Anything to the first power is itself. 2 squared is 4. 2 to the third power is 8. We can see how this input value of an exponent gives us an ever growing output value. So my x and y intercepts are going to be x-intercept of none and y-intercept of 0 in for x, and a 1 out for y. And again, the same rules apply. You can always go to your table of values and you can see. Here's what's really cool. Notice as my graph gets negative and negative, my value gets smaller and smaller and smaller. It's never negative. You see this negative value here, that's scientific notation. But if you look at my graph doesn't ever cross the x-axis. It's never, ever, ever going to be down here. So that's an interesting conversation when we go to start talking about domains and ranges. So when we talk about the domains for an exponential function, guess what? Anything can go in. Any number can go in, and any number is going to be able to be a possible input value. For my range, however, everything is going to approach 0, and for this function, get higher and higher. So we'll go back to looking at, see how this graph doesn't ever cross that x-axis? My range values are going to be as close to 0 as they can be, never crossing into that negative side of the coordinate plane. Okay, so when we look at our end behavior, as x approaches negative infinity, y is going to approach, and as x approaches positive infinity, let's take a look at what y approaches. So again, we'll go back to our graphing calculator. As x gets smaller and smaller and smaller and smaller, it's going to approach y, which is going to be at 0. As x gets bigger and bigger and bigger, it's going to grow and grow and grow and approach positive infinity. All right, let's see if we got everything. We talked about our intercepts, our asymptotes, our domain and range, and our end behavior. So then what ends up happening is we can take these exponential functions and apply the same kinds of transformations. So when we look at this value up here that's with x plus 2, it's going to have that same transformation as our k. So when we go back and revisit our y is equal to a times whatever's going on with x, and then k on the outside, this conversation here ends up being the same as what happens with x. So this entire graph is going to move to the left 2. So when I go to enter it into my graphing calculator, I have y is equal to 2. To that, I'm going to go ahead and make sure that my x plus 2 is inside parentheses, or if you have a newer calculator, it's up into the exponent area of the equation. When I look at the graph, I can see that this whole graph has been shifted this way too. So when I go ahead and I look at what happens for my horizontal and vertical asymptotes, again, or my intercepts, again, I'm not going to have any x-intercept because y is equal to 0 is going to be my horizontal asymptote. I'm not going to have a vertical asymptote, and I'm not going to have any discontinuous points. When I go to find my y-intercept, I'm going to go ahead and look. When I have an input of 0, I have an output of 4. So that y-intercept is going to be an input of 0, gives me an output of 4. When I go to discuss my domain and range, again, anything can go in to an exponential function, but my range is only going to be from my asymptote up to infinity. So that left-right movement doesn't change my domain and range. And guess what? It doesn't change as x approaches negative infinity. Y is going to approach 0. And as x approaches positive infinity, my y is going to approach positive infinity also. So notice this shift to the left of 2 doesn't change what happens with my graph. It still never crosses this x-axis, and it still continues on forever and ever. If you want to compare with what the other graph looks like, you can go ahead and graph them on the same coordinate plane. There's my original function there, and you can see when I added 2, it shifted to the left. Okay, wait till you see what we're going to do with this next function. So with this next function, we're going to take note of a couple things. First of all, this negative sign is going to make us reflect. So when we list our transformations, we're going to have a reflection. And this means that instead of moving to the left 2, I'm going to move to the right 2. So we'll go ahead and take a look at our x and y intercepts. Let's graph this first. So we'll clear out, let's leave our parent function in there, because then you can say the opposite of 2 to the x minus 2 power. Notice here we're going to have our reflection as a negative out front, and this graph is also moved to this way. So this graph here is my parent function. That's going to be my new or my transformed function. So when I talk about my x and y intercepts, again, I'm not going to have any x-intercept because that y is equal to 0 is my asymptote. All right, let's talk about our y-intercept. If we go to the table, we can go ahead and see my y-intercept of a 0 as an input is going to give me negative 0.25 as an output. And we have no discontinuous points for this graph. Let's talk about domain and range. For domain, again, anything can go into this function. Our restrictions with the exponents are going to talk about what can come out. So we have everything from negative infinity up to, but not including 0. Because of that reflection, as x approaches negative infinity, where is my graph going? Y is going to approach 0. And as x approaches positive infinity, my y is going to approach negative infinity as it's getting smaller and smaller and smaller. All right, so this is an interesting one. We might end up just skipping this one. We haven't talked about logs or how to graph this yet. Some of you have a calculator that can graph this, some of you don't. We're going to go ahead and just skip 10 and 12 for now. So let's go ahead and work on 11.
Yeah.
All right, so this one, we're gonna skip these logs for now. We'll come back to them some other day, but not today. So here we have f of x is equal to 3 over x. We'll clear these out and we'll say 3 divided by x. Go ahead and take a look at the picture of that graph, and you'll notice it's so similar to the first one we started off with. It just has a slight stretch to it because of that 3 there. But notice it doesn't change a lot of our conversation about the x and y intercepts, which are going to be none, because our vertical and horizontal asymptotes are again going to be our axes. We don't have any points of discontinuity, and when we talk about our domain and our range, our domain is going to be negative infinity up to that asymptote, and then the union of that asymptote on to positive infinity. And my range is going to be negative infinity up to that asymptote, and then that asymptote on and on. All right, so here's something. If you have a newer calculator and you want to play with these, you can, under math, if you go, there's a log base on your calculator that this calculator doesn't have, where you can enter these in. Take a look at these. We haven't talked about logs yet, so don't worry about them. All right, task 1 complete. I'm proud of you for tuning in and listening and getting back into this with asymptotes and domain and range.